So guys, in this video we're going to be learning how to solve calculus and different aspects of calculus. So we have calculus being divided into two segments, which is the differential calculus and the integral calculus. So the differential calculus has to do with us studying the limit of a function, power rule, first principle, function of a function, which is also known as chain rule, product rule, quotient rule, implicit rule, and the application of differential calculus. Why the integral calculus has to do with us using algebraic substitution to integrate, then trigonometric substitution to integrate, and the integration by path, and we also have the integration by partial fraction, and lastly the application of the integral calculus. So do you understand, guys? Go. So guys, in this video, like we said, we are going to be solving questions pertaining to the function, limit of a function. So as usual, I will do some of the examples and the audience will do the rest. So but I'm only going to be doing number 1 and number 3, of which the audience are to do number 2 and number 4. So now let's take number 1. How do you find the limit of a function? A faster way without stressing. All you have to do is, since they said that limit your x as x approaches 1, so all you have to do is just put the value of your x into the function, and your answer remaining is your final answer. So that would be 4 open bracket 1 to the power of 3 plus 3 open bracket 1 to the power of 2 plus 2 then 1 then minus 2. So we'll be having 4 plus 3 plus 2 minus 2. So if you do this, your final answer is going to be 7. So 7 is our value for the limit of this function. So 7 is our value. Now let's do number 3. Number 3 has to do with us finding out or factorizing out this, because x squared minus 16 is possible to be divided by x minus 4 by factorizing it. So how do we factorize it? That will be x plus x minus 4, which is one of the values that we're going to be having, and x minus 4 over x minus 4. So what we have here now is cancel. Sorry, I forgot plus 4 I mean. So cancel. What are we left with? We're left with x plus 4, which is 4 plus 4, that's 8. So our final answer is 8. So the limit of this function is 8. So guys, try number 2 and number 4. All you have to do in number 2 is impute the value of x into this function and have the final answer. Then number 4, you have to what? Factorize. This 9x squared minus 1 is a perfect square. So you use the value method called difference of two squares. So you use it to solve that of number 4, which was the same application I used in number 3. So guys, try them out. Do you understand? So guys, this is power rule, which is also known as the derivative origin. That is what made differential calculus to be originated. So now in this part of it, if we have f of x to be ax to the power of n, now you will hear a common statement such as dy over dx. So this value or this statement means change in x over change in y, just like you have it in your slope, where your m is equivalent to change in y, that is y2 minus y1 over x2 minus x1. Or you see statements like this, change in y over change in x. So they are all the same, but this is how to do them mathematically without using a particular line, maybe the y-axis and the x-axis. So that's what we're trying to do in calculus, differential calculus to be precise. So now, when you hear the statement dy over dx, it means that first of all, you multiply the power of this, with a, that will be a times the n. Then what you do next is subtract 1 from this power here, so that will be n minus 1. So final answer will now be a n 2x minus 1. Do you understand? So now let's take an example. Let's say we have 3x squared. Do you understand? So we are being asked to find the y over the x of this. So 2, like we did here, 2 times 3 is 6, then x. Subtract 1 from this, that will be 2 minus 1, which is equivalent to 6x. Do you understand? So this is how to use power law. Now let's now go into doing some other examples of power law, maybe in terms of function, longer functions like that. So now if I have a longer function like this, let's say f of x to be 5x cubed plus 6x squared plus 4x plus 9. So I say we should find dy over dx using power rule or the derivative origin. So that would be 3 times 5, that's 15x squared plus 2 times 6, that's 12x, because 2 times 6 is 12, then minus 1, that's 1, plus invisible 1 is here, 1 times 4, that's 4, then x, then 1 minus 1 is going to give us 0. So because anything raised to power 0 is 1, so 4 times 1 is 4, then plus. Now, whenever you differentiate a constant, it always ends with 0, because differentiator of a constant will always give us 0. So there is no value to represent constant. So our final answer will be 15x squared plus 12x plus 4. So this is our dy dx for the power rule. So guys, acknowledge this. Do you understand? So guys, this is first principle. Like we did, we started with the limit of a function, we went further to power rule. Now we are on first principle. So how do we solve using first principle? But first and foremost, I want to let you know that whenever you are being asked to solve questions based on first principle, since you already have the idea of power rule, which is the derivative origin, there is a shortcut to know if your answer is correct or wrong. So the very shortcut to use is this. For example, now we have 3x squared. Just do it using power rule. You have 6x. So it means that when you are using this first principle, if you don't get 6x, you are not correct. So now let's start with first principle. What's the step 1? Step 1 is replace f of x with x plus dx. That is step 1. So it means that f of x is going to be replaced with x plus dx. So in anywhere I see x, I'll put x plus dx. So that will be 3 open brackets x plus dx all squared. So this statement means 3x plus dx, x plus dx. So if I open up the bracket, if I multiply all through, x times this will give x squared, x times dx will be x plus dx, then dx times x plus x dx, then dx times dx, that will be plus dx all squared. So if I simplify further, I'll have x squared plus 2x dx, that is this plus this, then plus dx squared, because this and this are families. If you look at it clearly, so then you open up the bracket, that will be 3x squared plus 6x dx plus 3 dx squared. So that is step number 1. Step number 2 is, after we have done this, is by subtract f of x from f of x plus dx. So you subtract it, so making it look like this, x plus dx, then minus x. So do you understand? So that will give us 3x squared plus 6x dx plus 3 dx squared minus 3x squared. So it is obvious that this will cancel out this. Yes, and so we are now left with 6x dx plus 3 dx squared. Do you understand? So after this has been done, the next step is by dividing the whole value that you have by dx. So f of x plus dx minus fx over dx. So if you write that in this place, that will be 6x dx plus 3 dx squared over dx. So after that has been done, it's possible you now factorize out dx, so you can divide it by dx at the denominator aspect of this fraction that we have here. So now, like if you remember when we have this value here, so we'll continue from here. So if you factorize it out, we're going to be having dx open bracket 6x plus 3 dx over dx. So you cancel out this. Yes, and so we're now left with 6x plus 3 dx. So the next thing you're going to do is to limit your dx, is to limit it as dx approaches 0. So it means that anywhere you see your dx, you should include 0. So that will be 6x plus 3 open bracket 0, that will be 6x. So your final answer is 6x. If you confirm from the power law that we predicted, that we said 3x if simplified will have 6x, is the same as the first principle. It's just that first principle is a kind of like, let's say, a long journey of power law. Yes, a long journey of power law, but you make sure that your answer with the power law are the same. That's how to know in an exam condition. Now guys, this is another example that we have here. You understand? So in this part of the first principle, you can see it's a different thing entirely, but it's easy. So what you just have to do is use power law to first confirm your answer. That will be 10x, because I told you the differentiation of a constant is 0. So it means that when you do the first principle of this problem, you are going to be having 10x. So now let's start. Step number 1, replace f of x with f of x plus dx. So if you do that, that will be f of x plus dx is equals to f open bracket x plus dx squared plus 2. So that will be 5 open bracket. Now, if you remember from the first question that we did, when we simplified this, we had x squared plus 2x dx plus dx all squared and plus 2. So I don't want to stress us by doing the other expansion then simplifying again, because you've already done that in the initial problem. So that will be 5x squared plus 10x dx plus 5x squared 5dx squared, and then plus 2. So the next step to take is subtract f of x from x plus dx. So when we do that, that will be f of x plus x plus dx then minus f of x. So that will be 5x squared plus 10x dx plus 5dx squared then plus 2, then the value of that will be minus open bracket 5x squared plus 2. Now don't be in a rush to just put minus 5x squared plus 2, because it will also affect the 2 value. So this will now be 5x squared plus 10x dx plus 5 dx squared plus 2 minus 5x squared then minus 2. So it is obvious that this will cancel out this and this will cancel out this. So we are left with 10x dx plus 5 dx squared. So that's what remains after all of this simplification. So the next step to take is f of x plus dx minus f of x will be divided by your dx. So this value here will be divided by dx. So 10x dx plus 5 dx squared all over dx. So which is, when you factorize out dx, you have the dx bracket 10x plus 5 dx over dx. So cancel out, that will be 10x plus 5 dx. So as usual, limit your dx to be 0, meaning anywhere you see dx you put 0. So that will be 10x plus 5 then that will be 10x, because 5 times 0 is going to give you 0. So guys, do not forget, do the rest of the problems that we have at the initial starting of this video, and also don't forget, like, share and subscribe to this video. And thank you very much, and see more of the videos next time, because this is not just the ending of the video. We have more laws and techniques to apply on differential calculus. So look forward to seeing the next of the videos. Thank you very much.